All right, so let's continue. So now that we've got our kind of core parent flames thing, we've fixed our issue with the z-axis noise and set the z-axis to 0. And it's looking quite a lot like the original. We're going to do our fire embers. So first of all, I'm going to do my little inspector trick. I'm going to take my second inspector, unlock it, select the fire embers, relock it, right? So now I can have my off-screen inspector to copy and cheat from. And what I'm going to do is I'm going to select the flames, right-click, choose Create Particle System to create a particle system that's a child, right? So now these simulations are going to both run together. But actually, just because I want to visualize just the embers for now, I'm just going to select the flames and turn off the emission module so that it's going to stop emitting temporarily. And we'll turn that back on in a moment. So now we can see another generic particle system. This one, we're going to use a little bit of randomness. So the first thing that we're going to randomize is going to be the start lifetime. And so we're going to randomize between two constants, two numbers. And the random values are going to be 0.5 and 3. So now the lifetime, we're going to see that some are going to last much longer than others, right? And we're also going to randomize the start speed to random between two constants, random between two constants, and that's going to be between 1 and 2. So now we can see that some are moving more quickly than others, some are lasting longer than others, and we're getting some nice randomness there. The next thing that we're going to do is randomize the start size, again, between two constants, right? We could do this between two curves as well if we wanted, and that's going to be between 0.05 and 0.1, right? So these are going to be quite small, as you can see. Then we are going to set the start color to a lovely sort of light orange color. And that's pretty close. And then, although, here, I'll just show you another trick. I'm clicking on my off-screen inspector. This is the actual color. If you want to get the exact color, again, just make a little preset out of it, right? There it goes. And this is for the whole editor. This is an editor preference, not just a project preference. So these are like a lot of colors from my other projects, and there's my new color. And so now, if I go back to this, I can just set that. Yeah, see, I was pretty close. All right, so a little workflow tip there. We are not going to tweak any of these values. We are going to adjust the emission to bump it up a little bit. We're going to go up to 20. Let's frame select it on this to get a little closer on it so we can see it better in the scene view. There we go. And the shape, in this case, is going to be the default cone shape. The angle we're going to adjust to make it a little bit wider. We're going to go for 32 something. And the radius is going to be a little smaller. This is all kind of season to taste stuff, so I'm not going to be super worried about this. You can just adjust to where you want it from. Now, we're going to not just emit from the base, right? The circle at this end of the cone. We are going to emit from the whole volume, right? And that allows us to choose the length, and we're going to make the length tiny, right? So, I mean, honestly, this could just be a circle, right? Again, this is the kind of stuff that you just get through trial and error, and I'm sure that was just Rourke playing around with the systems and got that. Okay, so that is fine there. Now, the next thing that we're going to set is going to be color over lifetime. And here, again, we just have a nice preset, which is this one that I saved from a previous, from the actual one. And here we're fading in, right? So we're starting at low alpha, going to high, fully opaque alpha, staying opaque, and then fading out, right? So right now, well, you can see it happening now, right? Because I assigned the gradient, but before you would see our particles popping in and out. Now they're going to fade smoothly in and out of existence. and they're going to transition from white to a kind of a more brown color, keeping in mind, right, that this is working in conjunction with the start color. So this white is going to be the start color, and then these colors are going to be mixed, right? So then we're going to go to a kind of a deeper brown as we get higher. So that's already looking pretty good. Then we're going to add our new best friend, noise. So let's turn on the noise module. Instantly, right, just looks so much cooler. I really love this thing. And actually, we're going to use something quite close to the default. We're just going to lower the strength. But of course, depending on the weather in the environment that you're simulating, right, you could add wind to taste, right? And we're going to keep the 0.5 frequency. We're going to use a little bit of scroll speed. Low, though. 0.5. Look at that. Look how nice that looks. The damping, we're going to keep on. I didn't mention it. Let me just read from the docs. The damping, when enabled, strength is proportional to frequency. Tying these values together means the noise field can be scaled while maintaining the same behavior but at a different size. So in this case, if we're adjusting the frequency, right, we're scaling the whole noise field. I love that there's this little visual preview. To me, I'm sort of having something visual like this really helps me to think about it. So yeah, it's looking awesome already. And then the last thing that we need to do is we're just going to make a few little tweaks to the renderer to get us to that final effect. And actually, you know what? I've had the wrong other one running. Let's just turn this guy off temporarily. Turn off the emission for the one that we just copied and turn on the embers. And you can see we've already copied it quite closely. The only difference is a little in the texture and the renderer. You can see there's a little stretching going on, which looks very nice. So let's go and fix that. So we're going to go back to our particle system that we're working on, and then in the renderer, we just have a nice, simple embers particle material. You can see that's really just another dot, right? Just slightly different, which looks very nice. And then what we're doing is instead of a billboard, right? And if you don't know what a billboard is just a quad or a plane that always turns to face the camera, right? And usually has a texture on it. So if you've ever played like old school first-person shooters like Doom, right? All of the characters are just flat sprites that are billboarded and showing you a different sprite if you're looking at their back and rotating towards the camera, right? Very common technique and much more efficient, right, than having each of these be a sphere, for example. They're just a bunch of little flat planes, which is pretty cheap to render. And that's one of the reasons that particle systems are performant, right, is they're using these little rendering hacks. Okay, so, or tricks, I should say, right? And so what we're going to do is we're going to switch this from a billboard to a stretched billboard. And you can see we're getting this nice streaky movement. And we've got a pretty tight match for our original embers. So now let's turn back on the emission for our flames. And we've got something that's really looking pretty nice. The only component that we're missing are the particle-based lighting, which is what we'll do next. But first, let me take some questions from the chat. Okay, Harry Studio asks, is there an unlit shader that allows you to have an emission value? Because, for example, for sparks, I would like them to shine bloom in the dark, but for the shader to be picked up by the bloom post-processing, it needs to have an emission value, and I don't want to use the standard shader because of the unnecessary overhead for a simple spark. Sounds like you need to write yourself a shader, my friend. I don't know if there's an out-of-the-box shader that does exactly what you want, but I would assume that you could certainly write that shader yourself. The sparks, I think, have an HDR value in them. We'll look at that in a second, but they are using the standard shader. I think if you wrote a shader that used HDR values, those should bloom for you. under whatever circumstance. But honestly, this is getting a little beyond my level of skill, and the short answer is I don't know. Yeah, the suggestion to make the bloom in the texture itself is a nice workaround. That definitely would work. Yeah, I mean, fake bloom, I don't know, man. I mean, none of the stuff is real, right? The bloom is just a post-processing shader that's being applied to the whole image. I mean, one way you could think about it is you could just say, again, this is getting out of my level of expertise, but you could just render all of your sparks to one buffer and only process that buffer with whatever bloom shader you want, right? The bloom shader just samples the whole buffer output from the camera and applies a post-process effect to it. It's not like something physical, or it's all fake. It's all just post-process shaders being applied to the whole camera image. So don't get that twisted. There is no such thing as fake bloom or real bloom. It's just a question of how bright does the value have to be before it blooms, right? Like, yeah. Yeah, as Nunez says, you could use 2 different cameras. You can use special shaders. Yeah.